This is going to be a very short video about the concept of completing the square. Completing the square is a technique that can be used to take a quadratic equation that's in the form ax squared plus bx plus c and converting it into a form that's a times x plus something squared plus a constant. And it's not c because the number is going to change, but it's going to be some number. This is useful for solving quadratic equations that don't factor easily. It's useful for graphing quadratic functions. It's even used in calculus with some integrals, and even as you move up into higher mathematics. But it's definitely a skill that students need to be able to do. So let's suppose that we have a quadratic equation, and let's say that it is x squared plus 6x minus 7 equals 0. Let's say, for example, we kind of take this quadratic equation and put it into vertex form of a parabola. That means it's going to look like this. Okay, so what we need to do is break this apart using the completing the square technique. And the first thing you do when you complete the square is you determine that the coefficient of your x squared term is 1. We've already got that, so I don't need to do that step. The next thing you do is you move your constant to the opposite side of the equation, and that's just because the completing the square process doesn't require us to use that. But when you do it, you want to leave a space here, and this is where the completing the square part comes in. The way we come up with this number, pretty simple concept. We take half of this number, which is 3, and then we square it. And a lot of times you'll see that done with a little box. So we take half of this number, 3, then we square it, which is 9. And since we added 9 to one side of the equation, we're going to add 9 to the other side of the equation. So then we have x squared plus 6x plus 9 equals 16. This factors into x plus 3 times x plus 3. And then it gives us x plus 3 squared. We can move this 16 back to the other side. And here is our vertex form of this parabola. So that's completing the square. Now, a lot of students don't get that very easily, so they need to see a little more concrete demonstration of it. And that's what I'm going to do right now with the algebra tile. So I'm going to start out with my x squared, and I'm going to put on my 6 x's. So what I have here now, if you look, I have my x squared piece, and I have my 6 x's. To complete the square, I need to fill in this area. Well, if you look and you want to think about it like this, how many of these little squares will it take to fill in this? So what I've done here is added 1, 2, 3, 4, 5, 6, 7, 8, 9 units to my problem that weren't already part of the problem, and that's evidence right here in my original completing the square process. This is where I added in the 9, and you can see these 9 were just used to literally complete this square. So that's one of the ways you can think about completing the square. And this blue x squared term would give us an x and an x, and then we have 3 here, 3 things here. So that tells us that our factors are x plus 3 and x plus 3. Now, just like over here when I took this 7, this negative 7, and I moved it to the other side, well, that happened here. I just don't illustrate it with the tiles. So I still have my x plus 3 times x plus 3 equals, I had the 7 over there, because I moved it over, because I didn't include it in my tiles here. And also, if I add 9 tiles in, I have to add 9 to the other side of my equation. So I still get the same thing, x plus 3 squared equals 16. Subtract 16 from both sides. I get x plus 3 squared minus 16 equals 0. So that's how completing the square can be done with algebra tiles.